Okay, thanks a lot. Thank you, Christian, for introducing and having the chance to present Designwerk and our approach to batteries. So welcome you to my presentation, which is about batteries, which is about electrification of commercial vehicles, of vehicles standard, which is the standard business from outside in form of trucks, but also for third partners. And so I'd like to introduce at first Designwerk, and later on I'll go to the two topics. But let me please make some remarks at the beginning. So some basic slides. What's that? That. So the relevant CO2 emission nations are mostly those ones which are the most wealthy companies. So the higher the wealth of a nation is, the higher is the emissions of CO2. But currently, despite of different international effort, nothing has been really approved. So our thinking is that we have the right offer to make a change, to offer technologies for driving, charging, and storing. That's our approach, and that's why Designwerk is engaged in this commercial truck to commercial battery business. So I want to introduce Designwerk, mentioned already, and the first thing which might be interesting to know that Designwerk became in 2021 a part of Volvo Trucks. Recently, so end of last year, Volvo Trucks overtook 100% of Designwerk. So we are kind of the small electromobility unit within the corporate organization to electrify, to offer different services in terms of products for the electromobility, which means also that our focus is not only products but also services within the Volvo Group. But basically, Designwerk consists of three pillars with products, which is the electric truck business. We had no truck when we started with trucks. We had no batteries, so we designed batteries. And at least we had no charging technology, so we developed chargers. And one outcome of this effort was the MDC row with 22, 44, and 88 kilowatt MDC DC charger. And last but not least, the basis of our business is normally, or has been, and is still contract development. So we are working together with partners and are electrifying commercial vehicles or providing solutions for the electromobility market. Designwerk is currently a company with around about 200 employees, which are mostly located in Winterthur at its headquarters in Winterthur-Wülfling. We have two other sites in Winterthur for logistics and charger production, but battery production, e-truck production is in Winterthur at this site here. Here's the hall for the e-truck production. This is the battery production. And also in the background, devices or facilities for development for our engineers and for the whole company, for the offices. So the batteries. As I mentioned, we provide at first batteries for our own trucks. So we designed batteries which fit which can be fit into a truck. And which apply to the requirements of a truck. Typically, we use also our own batteries when we do an electrification job, because that's what we know, that's where we are experienced with. So our approach is to deliver reliable, safe, compact, intelligent, with good BMS, efficient battery systems, and those are offered with a tested in everyday use within our trucks, which are sold European-wide to be integrated, or which are integrated into our trucks. So that's the basis. So we have an internal customer, and of course we offer them as well for external customers. And that's the situation, how it looks like. That's a 4x2 truck with in total 4 batteries between the two axes. This is a 250 kilowatt-hour battery. This is a 125 kilowatt-hour battery. So in total, we have 750 kilowatt-hours. That's one typical application for long-haul truck, which will be used for delivery jobs. In this concrete case, has been used. It will be used in Germany for delivery service. Sorry. Basically, our battery systems are designed like that. So we use standard, more or less standard modules. For example, VDS355 NMC modules with prismatic cells, one S45 4P cells, or we get also from an Asian supplier LFP modules, which are just customized for us to be integrated in such a battery system architecture. As you see, for example, for this battery, which has 250 kilowatt hours and will be operated with maximum 400 volt, we have a battery system where 16 modules will be located on a cooling blade, distributed on 6 layers, which means 16 by 6, which means 96 modules will be integrated in such a battery system. The cooling blade will be flooded with cooling liquid, water and glycol, 50-50 through this battery system. So that's how it will be cooled. The whole battery stack will be integrated into a housing. It's an aluminum housing, including an insulation with 24 millimeters insulation on all sides. Insulation for thermal insulation, but also for mechanical protection, because 24 millimeters are fine or good to cover the batteries at best, in the best way against influence impact from outside. You might remember when I showed you the truck. It's quite open. It will be covered by a metal blade, but basically it's open, and this insulation has already, and the housing has already protected the battery system pretty well against influence from also in the construction business traffic. So that has been proved as a quite valid solution. So each battery system has at minimum one battery management system. If they will be connected, one will be automatically the master, the others will function as a slave. So the hierarchy between the batteries will be organized by themselves, by the BMS. Every cell and every battery system in total has a degassing unit and interlock signal for all the connections in between. So that's what we experienced until now. We have an inner safe battery system, which does pretty nice job within the trucks we already delivered. But I mentioned already, not but just good to know. We started with NMC batteries, but we entered also into the LFP battery business. So we took both. We are using both. One side also to see to get an idea of when we use which battery system. For example, the NMC battery has, of course, a higher energy density, so lower weight, connected to a special electrical output. This is, for example, helpful when we designed a battery for a customer where the situation, the space has been quite narrow, and it wasn't possible to integrate an LFP battery. The charging power, in terms of charging power, NMC is still advantage and the number of cycles, of course, will be a better argument for the LFP battery. The cost per storage capacity, we expect for both sides more or less the same effort, but the cost per kilometer is due to the number of cycles, possible number of cycles, better for the LFP battery system. In terms of sustainability, is of course LFP battery better, but for cyclability, we expect from both batteries the same behavior, the same feature, the same benefit. But so we started with NMC, but LFP, we expect LFP to gain more momentum, more relevance also within the truck business, because at least our Asian supplier, especially Chinese supplier, focus more and more on LFP. So we expect NMC will get less importance while LFP will gain more importance. And that's how we approach. We buy the LFP, the NMC module, for example, the VDS355, integrate it into a battery system such as housing, and we design or we produce, develop, produce, and sell the battery as a 250 kilowatt-hour system with 400 volt maximum, or currently in construction or in development, a battery system with 800 volt and 250 kilowatt hours. Half the size, more or less, in terms of outputs is the battery with 125 kilowatt hours and 400 volt maximum. And this is a customized battery, which is designed for also for small commercial vehicle. This will be half again of the 125 kilowatt hour battery with 65 and 400 volts again as a maximum output. When you come to the LFP battery system, we have two modules which are integrated in such a system, and we have already developed or using in our trucks and for customers the 170 kilowatt hour battery system with 400 volt maximum. This is based on an LFP, in this case for long life. This is really a difference between both batteries. And still under construction for a customer, we are designing a battery which is really huge, 2.5 tons, also for commercial truck with 340 kilowatt hours and 800 volt maximum voltage. So for both for LFP and for NMC batteries, we expect currently. We expect in the whole industry, but also for Designwerk, we saw already. We expect further increase of energy density. So you see, for example, the 250 kilowatt hour battery, which is more or less here at this point. At 257 watt hours per liter. The smaller the battery is, the smaller will, of course, the energy density. And in between, you see the densities, energy densities of our competitors, which have sometimes smaller, but which have not that high value. And that is, of course, so do we think about that? One reason we do such a big battery system, we're designing such a big battery system also for the 340 kilowatt hour, because this enables us to have a compact system with high energy density based on reliable battery modules. And this is our approach to increase further the whole battery system, not to have 4 battery systems to deliver 250 kilowatt hours, but one with 250 and not different unique single batteries, which of course don't allow high energy density. So we faced the last 7 years about 90% increase in energy density per year. It makes up something like 9.5, 10% per year. So we expect we will see in the near future 300, perhaps 350 watt hours per liter with this LFP or NMC battery technology. We'll see. Probably we will see also battery technologies, but we are still focus at the moment, at least on LFP and NMC, and that's where we expect the 300 and perhaps 350 will be shown in the near future. We expect. In order to supply battery systems which are safe and reliable for our customers, we of course have to do certification. As that's one topic we have to cover, but that's one quite important. So we do all the let the battery tested according UN ECR 100 revision 3, vibration, thermal shock and cycling test, mechanical shock, and so on. For revision 3, we are implementing the warning signal 5 minutes before the thermal event, and we designed, or we decided also to use 100 as a basis for EU conformity according to the EU Battery Directive. So this Battery Directive stands for different expectations or needs we have to fulfill. That's underway at the moment. It's quite a high effort, but that's the basis to bring the battery into the market. That's one part of the story. The other one is we do the contract development. So we electrify, we offer services in terms of which are used in this or needed in this electromobility industry. For example, when we start with the contract development, we talk about the work starts with a study, with feasibility study from the project, to also to estimate costs and time schedule, and this goes until the prototype or pre-series, or at least the series level, to provide for our customer vehicles which are electrified, completely electrified, so no more diesel engine, but completely electrical vehicle. We use process from the automotive industry and try to provide the best innovative engineering and industrial design, also the cover of this vehicle. We do it for vehicles, for storage and charging solutions, and are proud to have the experience from more than 100 projects where we did already such an electrification or project within this industry. For example, some might have been seen from you. We did the postal delivery vehicle, the iBAT DXP, where we had our input juice booster charging cable. We had our input at the microline, which is basically a new work or a new edition of the BMW Isetta, which is in our premises, and which has been influenced by Designwerk, not totally developed, but we had an influence. We worked on the ground power supply system, and the next one was also, you see the mega chargers, that's already still a prototype, but it's already installed at a customer. When you design trucks with 1,000 kilowatt hours battery capacity, you need to consider how can this truck be charged in an appropriate time. So we have customers which run such a 1,000 kilowatt hour battery truck, and this should start in the morning as a car porter to South Germany to get cars, come back at noon. During the lunch break, the battery has to be recharged, and the truck can start again in the afternoon to do next run to get more cars from the customer. So that's why we are implementing. We are sometimes also still working on that. The APQ process, which means it's advanced product quality planning. So we want to offer as a service engineering provider, or as an engineering service provider, if we want to electrify vehicles, we need to have a standard. We need to have a systematic phase-based approach with a focus on error avoidance and want to minimize the risk and deliver complete documentation. And that's very helpful to have a good structured process to ensure the quality and satisfaction, of course, of the customer from development to the starts to the delivery of prototype, pilot system, pilot vehicle until the launch of the serious production. That's also for us a challenge. Designwerk comes from an engineering approach, and systematic work is also for us the key to stay in the market, to provide the services. So that's why we are focusing towards such a process, and we see it also in the discussion with our mother company, with Volvo, that we need to improve to become something like a Tier 1 supplier in terms of for batteries, for charging devices, to deliver the right quality and safe components for our customer, which is also Volvo at least. So some examples. Here you see the sketch of a Designwerk truck, which consists of a leather frame where the module and a cabin has been designed and integrated with low voltage half HVDU, the PDU, and the high voltage PDU down here. There's a gearbox, one-step gearbox with 4 drives, which will be connected to the wheel via this axle, to batteries in between those crossbars, and onboard chargers within the module and a cabin, but the charging port next to the battery. So that's one approach which we realized in our trucks, but also in a customer vehicle where it has been a bit more compressed, a bit more close together. That's another example for when you see such a truck. There's also a battery in between the 2 axles for a tractor truck. This module in the cabin with all the devices, a bit similar to the picture I told you. So for such a truck, that's where I can talk about. Unfortunately, I cannot talk about our customer project, but here you see one with a drive with 500 kilowatt gearbox, as I mentioned in the MOOC. In that case, we had NMC batteries, system voltage of 400 volt, and charging options 444 kilowatt AC and 350 kilowatt DC, CCS type 2. And we can offer for that kind of truck a capacity between 375 and 1,000 kilowatt hours. This is how it looks like. The battery architecture gives us the freedom to integrate it as we want to integrate it. So we have different installation situations. In that case, 500 kilowatt each behind the cabin, which means plus 102 times 125 means 755 kilowatt hours on the truck. In that case, 1,000 kilowatt hours between 2 axes, and here 500 kilowatt hours behind the cabin, lengthways to the direction of travel. That means that is, for example, for what is it name? Reinigungsfahrzeug, where all the supplier, all the devices for the machine are around the batteries, and battery has to be integrated here. That was the only place we can use. And that's how we try to figure out, like in a Tetris game, how can we put in our batteries into the chassis, into the application of the truck to fulfill the energy demands. Nevertheless, next step, we go to the charging business. That's not our project, so we supplied only in hardware, our tractor truck and batteries. This is battery swapping station in between Berlin and Dresden and Lubbenau. We were proud to deliver a couple of batteries and this truck. This project is still going ahead. This was a public funded project from the University of Berlin, but this is another approach. We, in general, see 3 possibilities to charge trucks, electric trucks. Mega charging, this is the focus of Designwerk, because we think that batteries, if it's battery backed, such a mega charging, we can deliver and provide energy to trucks anywhere. That is a battery swapping station, which is another approach, but that needs also battery kind of a system environment where the truck and the battery swapping station will be used together for defined and always constant use of truck fleet and this battery swapping station. And the third option is the overhead line with pantograph, but we don't see the future in that because the effort is too high. And I guess the 2 parts, battery swapping and mega charging, are the 2 technologies where we expect this to be done in a perfect manner. But we see also battery swapping will be used in China quite intensively, but we don't expect this to be widely used in Europe because of other market structures, other market player. But on the other hand, we designed this mega charger, battery-backed mega charger, which has the advantage that it can be used anywhere. We don't need to adapt the grid connection, or we need not to have high energy output or power connectors to the grid, because the battery has can be stuffed, equipped with between 500 and 2,000 kilowatt-hour battery capacity. This makes it a bit more independent. So we designed such a battery mega charger, which has been also delivered to the first customer. But mainly for our trucks, we use such a mega charger. Sometimes we offer also mobile chargers, 88 kilowatt. The other mobile charger is 22 and 44 kilowatt, are more relevant for the electric cars. And here you see such a battery pack charger with remember the more or less 800 kilowatt hours battery capacity. This is already installed in Alteshofen with together on site at Gallica, connected to logistic center where they installed almost 2 gigawatt peak solar power, which gives about 1.8 gigawatt hours electricity. I guess the roof has about 10,000 square meters. So this connected with a mega charger makes it quite effective as a system where you can run also commercial vehicles with solar energy, because the excess energy which cannot be used will be used for households, for the environment, but mainly it can be used for the trucks, and those will be operated so basically only with solar energy. And so we have another customer which is going to do the same thing in Germany, where it will be connected to the grid on its own facility, and that makes it much more efficient to use solar energy instead of providing it to a grid with a low feedback, feedback tariff, but it can be used for such a application within its own fleet, own truck fleet. So short view on our trucks. Also operated only with our own batteries. So you see for different trucks, we try to, so Designwerk is more or less a niche manufacturer of trucks. The OEMs like Daimler Trucks and Volvo are established the standard application. We do the special trucks where it's not yet interesting for the OEMs to offer the solutions. So, for example, like a snowplow, that's not very interesting for an OEM. So we offer such a solution. You see also the energy demand. Such a truck can be only operated with a mega charger because when it's used, it will be used 24/7, and it will be used. Will have no use for another 10 months. But then for that short time, this makes it's feasible, at least in technical dimension. That's, for example, a truck for long distance parcel distribution. It ran already 25,000 kilometers a year, had an average demand of 116 kilowatt hours per 100 kilometers, so that's pretty low to compare it with a personal vehicle, electric car, which is about 20 kilowatt hours, so that's quite nice value. But that shows as well that the electric trucks with batteries are already comparable with a diesel truck, and can replace a diesel vehicle. And that's our approach to show and to see that this is, in our opinion, the future of public transport, of transport business. Battery electric vehicle is the key to low CO2 mobility. Yes, we think, of course, more than, for example, fuel cell electric vehicle. If you regard the whole conversion chain from the primary energy to use until the use in the e-drive, we have on the fuel cell electric vehicle side an overall efficiency of almost 18 or 20%. And on the battery electric side, we have an overall efficiency of nearly 80%. So it's 4 times better than for example, for fuel cell electric vehicle. And this is one discussion we expect. The battery electric vehicle will be in future the choice if you talk about alternative drives. And if you compare it with a diesel truck, a battery electric truck, and hydrogen fuel cell truck, and consider there might be an operator of 50 trucks, and the effort to run it with diesel will be 200 megawatt hours diesel per week. If you have an hydrogen fuel cell truck, we expect to have 375 megawatt hours energy in terms of hydrogen, which will be per week, which would need electrolysis output power demand of 3,000 kilowatt hours. A battery electric truck would consume about 80 megawatt hours per week, which would require only 600 kilowatt connected grid load for this industrial facility, which is more normal value. 3,000 or 3 megawatt will be picked with exotic, with high and also very expensive. So that's kind of a theoretical comparison to see what might be the basis for that. And if we go further on with that idea, you will see that For example, the CO2 emissions with the diesel truck are of course high, about 67 tons per week CO2. With a hydrogen vehicle will be 26 tons per week, and with the battery electric vehicle will be about or less than 6 tons CO2 per week. Also, always based on this conversion rate I mentioned already, because when we go from the primary energy to the use of energy at the e-drive, that's more or less the effort you have to invest, and that are causing such CO2 emissions. So, so in our opinion, it's very likely that battery electric vehicles will prevail over combustion engines before the end of this decade. They are significantly lower, have significantly lower operating costs, have the highest improvement rate of all technologies. The battery storage is a game changer. It will we are not by far not at the end of this development. We expect much more improvements beyond NMC and LFP, and the overall efficiency is outstanding, and that's is the basis of, in our opinion, that this will be very successful compared with a diesel engine, for example. So you won't believe, in 1918 in Hombrechtikon there was a electric vehicle which has about energy density from 28 watt-hours per kilogram. Nowadays, tractor truck with 6x2 and 1,000 kilowatt-hours has an energy density of 225 watt-hours per kilogram. So that's really an impressive development, and that's why we believe it will come like that electric vehicles have a big chance, a bright future, but it will take a while. So thanks a lot for your attention. If you have more questions, please let me know.
Yeah, thank you very much, Volker. Maybe I start. I see first questions coming in, but like you show at the very end, you try to compare diesel with electric, and lately the International Energy Agency published a study and say basically by 2030 about 95% of all truck drives in Europe will be cheaper to achieve with an electric truck compared to a diesel truck. Is that a figure that, with your experience and you know the prices of all the components of an electric truck, do you think that's a feasible number?
It's not easy, but it's feasible. At the beginning, it's like with heat pumps. The start investment is higher than a compared gas boiler, but the operating costs are lower, and that's kind of a comparable situation with electric vehicles in general, but also with trucks. In Switzerland, for example, we experience that a truck which has a minimum operating time, minimum distance per year, it can be a business case after 3 to 5 years, depending on better conditions for electric trucks at the moment, because the Lastschwerverkehrsabgabefeld will not be active anymore, and trucks are getting cheaper, batteries are getting cheaper. We have at the moment in China strong competition between many battery or cell manufacturers, so that leads also to lower prices. And that's why, yes, it's possible. It's not easy, but it's possible. It depends on our effort and success in reducing prices for the systems, for the truck and batteries. And batteries are the driver at the moment.
Okay. But so you see good chances that the transformation in the truck industry maybe could go faster than in, for example, in the cars, because it's purely cost driven, and if it's cheaper to drive electric compared to diesel, companies would potentially transform faster.
Yes, it will be possible, yes, but it's difficult to say whether it will be 5 years earlier or later. But we expect, and when we see also the development in Asia, there's a strong driver that it will be more cost effective. At the moment, it's a bit difficult time for all of our customers because at the moment, I guess the market is kind of consolidating. You heard probably about Northvolt, which couldn't stand in this competition when the Chinese manufacturers come up with lower prices. But it will happen, I guess.
Okay, thanks. So then let's start with the questions from our audience. So the first one asking question was Damian Areker. So he actually had two questions on the battery. So question A was, on which level do you need to place fuses or circuit breakers? Example, give a module or pack level. I don't know if you can answer that question.
Fuses and contactors, they will be put on pack level between, next to the hatch. They will be integrated within the battery between the high voltage connectors and the bus to the modules. Or did I understand it correctly, the question?
Yeah, I would understand it the same. So basically can we say on string level, right? Like you showed us a multi-string concept within one batteries. Yeah. And then question B was, what experience do you have with SOH indication of cell module suppliers? How good are they performing with regard to indication in the product sheet, data sheet? Yeah.
Good question. If we hope it would be better, it's according to our experience, it's more or less a part of the BMS, and the SOC or SOH, both will be calculated, and both have a certain quality which is not perfect and which could be higher. Also, when we talk about warranty for batteries, so that's still an issue. We need to improve the outcome of data. And for example, with some customers, we talk about using this data as a first indication. In an extremely in a worst case, we have to do the tests on the battery in our lab. If it's, for example, a fleet a battery which goes under, for example, 80% SOH, and which will touch any guarantees concerning minimum energy output.
Mm-hmm. But maybe if you might, I can add a few words, because we tested some of your batteries in the framework of the megawatt charger, right? And there basically the test results show that the batteries actually age better than in the data sheet. But of course, you showed that you have different suppliers, different chemistries. So I guess it depends.
Okay, the whole industry, at the beginning, most suppliers have been quite careful, promising anything like cycles and lifetime of a battery system. Currently, we see that the lifetime of NMC batteries, also delivered 4 years ago, are much better than we expected. So we have a battery operated in Sweden, a battery on a truck, which has a pretty low degradation or drop of energy capacity of SOH. So we are much about 90% after 6 years of operation. So the batteries are much better than we expected to see.
Mm-hmm. And to what corresponds that in kilometers, like this 6 years?
Depends on the size of the battery, which I don't know. I guess it's a kind of,
true.
This is a battery size of 680 kilowatt hours, and but I don't know. I know this truck has a yearly operation distance of about 80,000, 90,000 kilometers.
Okay. Well, yeah. When you multiply that by 6 years, it's
not bad.
Quite nice. Yeah. Okay, great. Then we have a question. I open the microphone from Andreas Fuchs. Give me a second. You just disappeared. How do I refine you here? Voila. Well, so Andreas, you can ask your question. Or maybe not. Maybe it's
Not yet.
yeah, I don't know. Is muted? Can you unmute yourself? No.
I unmuted. Yeah,
Yes,
I'm unmuted.
now we hear you. Good.
Okay. Question regarding thermal management. What is the maximum temperature inhomogeneity you allow across your battery packs? Is it 1 degree, 2 degrees centigrade? How perfect is the temperature homogeneity in your packs? And how many sensors do you have? What's the spatial resolution?
We have 2 sensors on each module. So in the big battery, about 96 times 2 temperature sensors. Actually, I don't know what is acceptable. We try to keep the sweet point with between 25 and 30 centigrade, but I don't know in which delta T we have from the beginning of over the flow field.
Okay. But so when you heat up a battery, how much time does it take until you say, well, it's homogeneous temperature across the pack?
So we don't look for homogeneous temperature.
You don't.
We can no, because of course the battery can be operated also with 10 centigrade ambient temperature. It will be not that powerful, or it will not be fully active, but it can be operated also at lower temperatures, not below 0, but of course, yes, it can, but it takes a while, and during operation it will be getting warmer, and then full performance will be given. But we don't need homogeneous temperature over the whole battery to start the truck, to start the operation of the battery.
Okay, thank you.
Good. Do we have other questions? I don't see any other questions in the chat. You can still raise your hands. Give you 1-2 seconds more. What I was wondering, you show like 400, 800 volt architecture. Do you see trends in the like for heavy trucks to go beyond that, over 1,000 volt? Or do you think like 800 volt will be the sweet spot?
So in my tiny world, I didn't see 1,000 volts for electric truck. I think that's mainly driven by the rail business, where we are not at home currently. We came from 400 volt because only for this level of voltage we had devices. We got only systems and parts for the truck on that level. Now it changed to 800 volts, so that we are more or less driven or forced to change from 400 to 800 volt, because parts are available, and sometimes it's getting narrower in the 400 volt area because some parts are not anymore available in that level, at that level. But I didn't see more than 800. Standard is 600 to 800 volt, I guess.
Yep. Okay. There came a question along here from Amira from ChemSpeed. Question: how did you build the TRL from the research to the current status? Well, that's very general. I hope you understand the question about the technology readiness level.
Pardon? Can you please
Yeah,
repeat
so
that?
the question was how you basically climbed the technology readiness level, you know, like how do you bring like new technologies to the market or to implement in your product?
That's a good question. At the beginning, from the beginning, we used existing material and materials which has been, for example, qualified from other companies. For example, at the beginning, we used battery modules from BMW, which has been qualified on that level from BMW. They have been quite well. And so our challenge was to design a system from different, more or less qualified suppliers. This was from time to time a real challenge because some parts are really qualified, some are not. So we had a lot of also challenges to overcome such problems with components like drives and compressors and so on. So yet during the situation with Volvo, it changed for us that we have much more steps from early phase of development, like a functional sample, from A sample to P sample, and serious production, which takes much more time, much more testing, and making sure that it works. But at the beginning, I'm sure that some parts we have been quite early and we had to pay for that because we had to improve our systems again and again, but it's getting better now. It's getting better and more reliable.
Well, Amira, she asked further, do you have any like collaboration with academia on different topics?
Yes, we do. We have with school in winter tour and other projects. We had this project with a technical university in Berlin. So there's a couple of projects. I don't know all of them, but there are some for evaluation of existing vehicles, for approval of batteries of modules with you, for example, as well. And so there is some projects are there underway. And we are open for that as well.
Okay, thanks. I would say with that, I don't see any other questions coming in. Thank you very much for the interesting presentation today. We see each other in 1 month, July 1st, with BlockSense and with the introduction of Swiss Solar. So I hope to see you again, and thank you very much.
Thank you too for your attention and your interest.
Thank you. Bye.